Ladies and gentlemen, um, this this course is an aberration. This course is an aberration, not in a bad way, but in the way that I was asked to substitute for the normal lecturer for this course for 2 years, and I am. It's been my great pleasure to try to introduce you to a set of material that I believe that practicing software engineers, software developers need to know in today's competitive but very exciting marketplace of opportunities. Within this course, we've covered a wide variety of different topics, and no doubt for many of you it's seemed like a grab bag of different miscellanea. It seemed like a cacophony of different sort of obscure technical corners of the technical universe. And I won't deny that it's diverse, but it's diverse with a purpose. It's diverse with a goal in mind. And there have been certain themes that have united it. One thing is the use of abstraction of different sorts, separation of concerns, achieving modularity. We've seen how we can use abstractions even to measure performance effectively. We saw that a profiler offers little benefit without abstraction boundaries in our code to say where it's taking more time. And while abstractions do take a little bit of cost on the time side, those boundaries can allow you to replace bad performing code with good performing code in a way that can be transformative and allow you to assign accountability for that code. Abstraction allows us also to capture intentions beyond certain areas of the program, to encapsulate and hide details in ways that are advantageous. We've seen a bunch of different types of abstractions in this course. Functions. Higher order functions amongst them. Functions which take functions as arguments or return functions as results. Class-based abstraction. An abstraction associated with type hierarchies. And we've reasoned about what it means to safely subtype another argument, and reasoned about the implementation challenges of successfully subclassing in a robust fashion. But we've also seen just recently, in words out of my mouth, no less than an hour ago, we've also seen some aspects of aspect-based abstraction. These cross-cutting abstractions that capture concerns that are not limited to one area of a certain code base, but stretch across it, and where we might need to capture the rules about where these things need to be placed in the code base in addition to kind of realizing them. And then finally, we've seen metalinguistic abstraction. We've seen that certain languages, ladies and gentlemen, have an easier time of expressing certain concepts. And all it will take is for you to go from the Scala version of your Conway's Game of Life to go back and look at the C version to see a gap there. But in other cases, the gap can be equally or as profound, the gap between one language and another. And I have argued from this floor the need to be able to use the right language for the job for the right area of a program. Often these days, I might even hazard typically these days, we build systems and programs not out of one technology, one language, but out of a set of interacting ones. Maybe it's JavaScript on the one side, together with PHP, together with Java in the background and SQL. We weave together a system out of many components, and when we talk about Python or Scala or Java, it's not a matter of choosing the language which you will master as a software engineer and continue to use for the rest of your career. It's actually talking about how to choose the right language for the job. There are certain things I would never use Python for, and there are certain things Python is great for. Glueware that knits together certain high-performing libraries, for example. Same thing with Scala, same thing with Java. So metalinguistic abstraction, choosing the right language for the job, is often a key to virtuosity in terms of undertaking work. We have a luxury as software engineers and as computer scientists of not only choosing the language to frame the problem, but also creating our own languages. And we are entering a diverse space here where languages are evolving very rapidly compared to the past few decades. And you will do well to keep track of that and to track new languages, whether it's Scala or Go or Ruby or what have you, as they come out to learn where do they best fit in, what areas do they excel at, and where do they have their shortcomings. Because all language, by Kolmogorov complexity principles, have shortcomings. Okay? And we've seen, in fact, monadic abstraction in a brief glimpse. We've examined two types of abstraction, and I'll comment more on this on Sunday. Abstraction by parameterization, whether it's parameterizing classic values as arguments, or a subtype of that dealing with functions as arguments. Type parameterization, where we can say that this is an array of X, of T, for a certain type. And we've seen how we can use currying to capture abstraction in a sort of segmented, staged way, to have stage computation, which takes some of its values early and some late. So that's abstraction by parameterization. We've seen how pattern matching in Scala, or in Haskell for that matter, where we get this match syntax and we sort of match certain parameters and can then use them, fits somewhat into that space as well. So that's one type of abstraction. Another type that I introduced the very first day, but have concentrated on, is abstraction by specification. Here, like all abstraction, we achieve generality by hiding details. We can allow ourselves greater flexibility by abstracting away from the detailed context and handling a wide variety of cases. Abstraction by specification, we're abstracting away from which implementation we want to use. And we're making certain promises for our class, promises for our methods that promise certain preconditions, postconditions, what this method will do, but leave wide open the evolution of the implementation of that method. And abstraction by specification is just as much needed in the method context as in the class context, and indeed, as we saw today, in the aspect context. You need specifications to provide both sides of a client, so a user and creator relationship, to be able to evolve their code bases without being forever entangled or forever tripping over each other's abstractions. I've talked some about safety and the ways that we work to achieve robustness and safety in the presence of abstraction. And we've looked at particular issues having to do with type hierarchies. Where to go for this? And I recognize that here we are over time and need to finish up here. I'm just going to take 2 or 3 minutes further. Where to go from here? Some of you are going on to internship. For those, some of you are going on to jobs outside the university, starting a career, which is fantastic. Those of you staying may be interested in some of the courses listed here, which build on certain aspects. In my world, there's no better applied example for software engineering than seeing a compiler, for example, 442. Some of the other courses, 435, 405, 394, and 381, have features as well. CMPT 371, as some of you in the room know, has a very different look at issues having to do with software development in real-world teams, with a particular focus on the process side and the side of coordination between many parties. The materials I present in this course are not privileged. I struggled a lot working long times to try to get you a set of materials that I believe would put you in a good position to take those steps into the world as a practicing software engineer or practicing software developer. But they're not privileged. Ladies and gentlemen, whether you're going into the world now for jobs or sticking around for a couple of years, this world is evolving very quickly. What you've learned in this class provides some value for the current situation, but it's incumbent upon everyone, whether you're staying here in academia for some time or you're going into industry, to learn on an ongoing basis, to invest in learning of new technologies but new concepts. But some of what we've learned here will impart lasting value in alerting you to reasons for certain types of technology innovations that you see out there, for making sense of what otherwise can seem like a dizzying array of sort of different developments. Whether it's monads, whether it's issues having to do with abstraction, need for robustness, use of multiple languages, performance concerns and scalability concerns, type hierarchies. These are all part and parcel of the innovations out there. And the principles that I've tried to keep you here, beyond the details of the technology, the Scala and Java 8s or whatever, those principles, I think you'll find them putting you in a decent stead for understanding, a lot of the innovations out there. But fundamentally, it is up to us, all of us, in whatever position, to try to stay abreast of these changes, because that's what will allow us to become virtuosos in the software engineering area, to shine where others atrophy, and to move on to the opportunities that are just too risky or too implausible for many practicing software developers. So it's been my great pleasure, my great privilege and honor to be able to be with you this semester. I've enjoyed this class a lot. I know there's lots of room for improvement, and I'm grateful for your accommodation and as we still work through some of the issues. But I'll look forward to seeing many of you on Sunday, and an even larger number of you on Monday. And I'll look forward to recording those sessions for those who can't be there. I do have office hours scheduled now, and I will try to be available for a lot of time at the time of that review session for those who have further questions. Thank you very much, and I wish you the best of luck your end of semester. Thank you. Good time.